On 25th September, Mumbai posted its second highest monsoon rainfall after 1958. The intense rainfall throughout the season has left several parts of the city submerged, disrupting traffic, shutting down transportation, cutting electric supply, and leaving Mumbai stranded on multiple occasions.
More heavy rain is expected in Mumbai today, but Mumbai, which has been pounded by heavy rain for the last couple of days, saw the situation worsen. The winds picked up, reaching up to 107 kilometers an hour. By areas received heavy rainfall, including Thane and the western suburbs. The weather department has warned of a flood-like situation in the low-lying areas.
Nearly 4 months ago, Mumbai faced similar danger from cyclonic storm Nisarga, which was the strongest tropical cyclone to strike the state of Maharashtra in June since 1891. Scientists are warning that the extreme rainfall event in Mumbai to an anomaly will become a recurrent pattern due to increasing oceanic temperatures. The city also faces a threat to its existence with the rising sea level. Let us dive deeper into one of the major feedback cycles driving these changes: the clogging of ocean CO2 sink. Carbon sinks are the systems that absorb and store carbon dioxide from the atmosphere. Earth has several carbon sinks including forests and oceans. The efficiency of these sinks is becoming more and more critical with the rising CO2 levels in the atmosphere. Oceans are one of the most critical carbon sinks as they have absorbed nearly one-third of the CO2 that humans have emitted since the beginning of Industrial Revolution. However, they are one of the most sensitive sinks too. The rampant increasing atmospheric CO2 is clogging the ocean sinks, setting in motion one of the deadliest feedback cycles that can significantly accelerate the climate change. To understand how the feedback cycles work, let us first understand the mechanisms by which the ocean absorbs atmospheric CO2. Oceans do this with the help of mechanisms known as carbon pumps. There are two main carbon pumps in the oceans. One is biological carbon pump, which is driven by the carbon absorbing life forms like planktons. And the second one is the physical carbon pump, which is driven by the physical processes like solubility and convection. Out of these, the physical pump has direct vulnerability to global warming. We are all familiar with the fizz of the soft drink, and as we know, dissolved CO2 in water is responsible for this fizz. Just like soft drinks, all liquids have natural tendency to absorb some amount of gas. This ability is known as solubility. The physical pumps in ocean absorb atmospheric CO2 using this mechanism. The CO2 rich water is sunk to the bottom of the ocean by wind currents. Here it reacts with water to produce bicarbonate through a chain of simple chemical reactions. Simultaneously, bicarbonate rich water is brought to the surface, making it ready to absorb more atmospheric CO2. This decreases the concentration of atmospheric CO2 and slows down global warming. However, as our experience with the soft drink suggests, increasing the temperature of the liquid reduces the fizz. In other words, the dissolved gas escapes the liquid. Similarly, the dissolved carbon dioxide in ocean starts leaking with increasing temperature. The warmer surface water makes it difficult for wind to mix it with the cooler bottom layers. The exhausted top layer can no more absorb atmospheric CO2, hence the name clogging of the ocean sink. Moreover, the solubility of CO2 also decreases with increasing temperature. Greenhouse effect is now accelerated as more carbon dioxide is deposited in the atmosphere than the natural sinks can absorb. This in turn increases the global ocean temperature, leading to even less CO2 absorption. The positive feedback cycle thus created is extremely challenging to stop once in motion. Roxy Kaul, who is a scientist with the Indian Institute of Tropical Meteorology and lead author with the IPCC Ocean and Cryosphere, suspects that the warm ocean temperature in the northern Arabian Sea result in increasing moisture and large fluctuation in monsoon winds. This leads to unusual monsoon patterns, extreme rainfall and other anomalies along India's west coast. It is high time for scientists, policymakers and citizens to come together and save the city of dreams from becoming city of drowning dreams.